Our last dosage calculation of this activity is another safe dose calculation where we need to determine whether or not our order of methotrexate is appropriate. And if it is appropriate given the dose guidelines, then we need to calculate how much we would prepare in our syringe. So the first thing I need to do is to read the information, make sure I understand what's happening here. So we are asked to use the dosing guidelines provided to calculate the appropriate dose range for this patient based on their body surface area. Now, in this problem, I am given a lot of information on this dose guideline here on the left. I'm given the route, I'm given the max dose, second column is the weight-based dose, and the third column is the BSA-based dose. And you can see I circled the body surface area base dose because that's what I'm asked to specifically evaluate. So what this is telling us is that there is a minimum value. I'll zoom out a little bit. We have a minimum and a maximum. For the minimum, this individual should receive 20 milligrams per meter squared. That per meter squared means we need to customize this based on their body surface area. In previous calculations, we've seen per kilogram. This is per meter squared. When it's per meter squared, we need to customize this by multiplying by their body surface area, by their meter squared. So I'm going in here and just writing in, putting in my placeholder for my dimensional analysis. I know if I multiply by their body surface area, I will be customizing this range for this patient. So let's go ahead and calculate their body surface area. I see that their height and their weight are given to us in the metric system. The formula is going to be their height times their weight, or their weight times their height, divided by 3,600, and we take the square root of that entire expression. When I put that entire thing in my calculator, I get 0.933333 repeating, and we round our body surface area calculations to the hundredths place. So this would be 0.93 meters squared. This is the value that I need to multiply by. I need to multiply the minimum and maximum range, or values in that range, by their body surface area. And when I do so, let's see what we get. When you take 20 times 0.93, you should get 18.6. And this is the minimum amount of milligrams that they need. When you multiply 30 times 0.93, you should get 27.9. For this individual, this is the maximum amount of milligrams they should receive. So somewhere between 18.6 and 27.9. When I look at the order is 20 milligrams. And that is good. That is between our minimum and maximum. So I would say that the order is appropriate. And it's because it is within the minimum and maximum milligram range. Now that we have established that this is an appropriate dose for this patient, given their body surface area, let's calculate how much to give. So I would be preparing a number of milliliters in this situation. This would be an IV injection, and I have a strength provided on the label of 25 milligrams per ml, knowing I can use either one of those ratios. That is the conversion I need to use to turn my milligrams into milliliters. In this problem, there are 25 milligrams in this drug. 1 milliliter of fluid contains 25 milligrams, and that came from the label. Yes, you could also use 50 milligrams in 2 milliliters. Now when we multiply, use our dimensional analysis, we have 0.8, and the unit is milliliters. So I would fill this syringe to 0.8 milliliters. A couple things to note here. When we're calculating how much to give the patient, we're falling back onto the order. I have milligrams in my minimum and my maximum, but those were used to identify whether or not the order was appropriate. Once we've established that the order is appropriate, that's the value, the order. That's directly from the prescriber. That's what we would need to convert into milliliters, not the other milligram values that are provided in the range.